Hello guys, my name is Mayur Naik. I'm studying in SVC Bangalore at IS department. So today's topic is hydrographs. Today's contents are the definition of hydrograph, then the components of hydrographs, then the purpose and importance of the hydrographs. So first let us see the definition of hydrographs. So what is an hydrograph? A hydrograph is a graph or a plot that shows the rate of flow, discharge versus time past a specific point in a river, canal, or conduit. It represents how a watershed responds to rainfall and snow melt event over time. So there are some key points about hydrographs. So let us go through it. They display the variations in the discharge of water with respect to time. The vertical axis typically shows the discharge, usually in cubic meter per second or cubic feet per second, while the horizontal axis represents the time. Hydrographs provide a visual representation of how quick water moves through a drainage system and how long the increased flow rate persists. They are essential tools in hydrology for understanding and predicting flood events, managing water resources, and analyzing the health of watersheds. Hydrographs can be represent various time scales from single storm event to seasonal or annual patterns. So now let us see the components of hydrographs. So we have got three components. So first is rising limb, then we have peak segment, and then we have falling. So let us go through all these three components as I mentioned. So first you have rising limb. So initial phase, we have mid phase, then late phase. Uh, so first let us see initial phase. So the rising limb starts with a gradual increase in discharge. This slow rise is due to several factors: interception by vegetation, depression storage filling up, and soil infiltration at its maximum rate. Then we have midphase. As these initial losses are satisfied, the rate of rise increases more, rainfall becomes direct runoff, and overland flow begins to contribute significantly. In your late phase, the limb rises more steeply as subsurface flow begins to contribute. A large portion of the watershed starts contributing to stream flow. Then we have the inflection point where near the peak there's often an inflection point where the rate of rise starts to decrease. Then let us see the factors affecting shape. We have rainfall intensity and duration. Then we have watershed size and shape, soil type and soil type, moisture conditions, and we have land use and vegetation cover. Second, we have peak segment. So formation occurs when the entire watershed is contributing runoff at the outlet. The characteristics are sharp peak, flat peak, and multiple peaks, so indicating rapid watershed response often seen in small or urban watersheds. Then flat peak suggests slower response typically of larger watershed or those with significant storage. Then we have multiple peaks can result from complex storm patterns, watersheds with uh, varying travel times and different sub basins. Importance of these are critical for flood risk assessment and management used in designing hydraulic structure. Then we have factors influencing that is rainfall intensity. Then we have watershed size and shape. Then we have canal network and characteristics. Then we have last falling limb. So the phases we can see here: initial rapid decline, inflection point, and gradual decline. As surface runoff decreases, Then we have inflection point marks the transition from predominantly surface runoff to subsurface flow. Then we have gradual decline, that is represents the depletion of subsurface. So what are these characteristics? So the characteristics are generally follow an exponential decay pattern. Then can be divided into segments representing the storage components. Then analysis. So recession analysis can provide the insight into watershed storage properties. Then the recession constant are often used in characteristics watershed response. Factors affecting the shape is watershed geological and soil property, then vegetation we have, then presence of aquifers. So this is a diagram of elements of flood hydrograph. So you guys can look after this graph and can have a better understanding of this. So what is the purpose and importance of hydrographs? So we have flood prediction and management, then water resource planning, watershed analysis, and environment impact assessment. So flood prediction. So if we predict with the help of forecast and timing and all, we can flood can be predicted. Then water resource planning. So we can have a planning reservoir operations and water allocations. And we have watershed analysis where we can analyze the watersheds. Then environmental impact assessment. So help evaluating the effects of land use changes on stream flow. And last we have dot management, then we have infrastructure design, then water quality management, then climate change studies. So that's all guys. Hope you guys understood. Thank you.